Alright, so for number 14, we defined n as the number of generations back because it says you have two biological parents, so that's one generation behind, back from you. And grandparents are two generations, and great-grandparents are three generations back. So that's why I define the variables. You need to always do that with the word problem. So here are the generations back, along with how many direct ancestors. Okay, so the question is, how many direct ancestors do you have if you trace your ancestry back 6 generations, and then how about 12 generations? So we need to come up with a rule, a formula. So this is a geometric sequence because I'm doubling. So in this problem, R is 2 and A sub 1 is also 2. So the formula or the rule is f of n equals the first number times the ratio, which is 2 to the n minus 1 for n greater or equal to 1. Now, the base and the a happen to be the same, so I could simplify this and write, this is like a 1 there. So you add the exponents and the 1's cancel, so you're left with 2 to the n for n greater than or equal to 1. Okay, so then they want you to find f of 6. So that's 2 to the 6th. Okay, so that's going to give you 64 direct ancestors. And then f of 12, so that's 2 to the 12th power. That's going to give you, again, punch it into a calculator, don't do it by hand. So 2 to the 12th power is going to be 4,096. Now for part B, it's asking, how would the explicit rule change if you're considered the first generation? So N1 would be 1, because that would be me, right? Just 1. And then the second generation would be your parents, then your grandparents, then great-grandparents. Okay? So you would say, the A sub 1 equals 1, and R equals 2. So f of n equals the first number times 2. Okay, so sorry about that. So I've got f of n equals 1 times 2 to the n minus 1 for n greater than or equal to 1. And then n would be number of generations. I'll just put gen. Starting with you. Okay, and so that would be the formula right here. Now you don't need to add the 1. You don't need to keep the 1. You can just write it f of n equals 2 to the n minus 1, n greater than equal to 1. Oops, equal to 1. All right. So for number 15, you have four steps in Sierpinski's triangle. And they tell you that the first one, this one right here, has an area of 1 unit, so that would be our A sub 1. So 1 unit. And then we have to figure out, okay, how does it change from here to here? Well, if you divide this triangle into 4 equal triangles, which is 1, 2, 3, 4, right here, the fourth one, this one right here is 3/4 of this one, because I've got 1, 2, 3 out of 4 sections are filled in. So that's going to be our ratio. Okay, so from here to here, 3/4 of this triangle make up this one, and 3/4 of this triangle make up that one. Because if you notice, this little triangle on the top is also broken down into 4 equal parts, and only 3 out of the 4 are filled in. Okay, so this part up here is what makes up this part right here. So the R is 3/4. You could keep it as a fraction or write it as a decimal. Okay? So f of n is the first number times the ratio to the n minus 1 for all n greater than or equal to 1. And again, you could keep, now it says write a sequence for the series of, oh, write the sequence, not the rule. So, okay, sorry. So this would be the rule. And the sequence would just be, I'll put it a different color, would just be 1, 3/4, and multiply 3/4 by 3/4, that would be 9/16. Multiply 9/16 by 3/4, that would be 27/64, because you multiply across like that. And they only gave you 4, so we'll just kind of, so here's the sequence. Alright, so for 15B, now we're looking at Sierpinski's carpet, and they want you to write a sequence. So we're going to write both, we're going to write the sequence, and then we're going to write the two rules, the explicit and the recursive, okay, because you always need to practice both of them. So I have, this is n equals 1, 2, 3, 4, and we have a sub 1 equals 1. Oh, and again, just like in part A, n is the iteration, or the step, and f of n is the area that is shaded. So the shaded area. Okay? Now, what's happening here? Let's say we divide the square into 9 equal parts. And why 9? Because we're taking out a square. And this works out so that it's every little square is the same area. So to go from here to here, I'm only keeping 8 out of the 9 squares because the middle one is blank. And the same thing happens as you go across. Now this pen is too thick, but the same thing would happen. Each one of those little squares would be divided into 9, and the middle one would be blank. So the R is 8/9. So for the sequence, we start with 1. 1 times 8/9 is 8/9. 8/9 times 8/9 is 64/81. And 64/81 times 8/9 is 512. And again, just use a calculator. Over 729. And keep going. So for the explicit rule, we're going to say f of n equals the first number times the ratio to the n minus 1 for all n greater than or equal to 1. For the recursive rule, remember you always start with, you have to have the two parts, the beginning or at least one of the n values. So in this case, f of 1 equals 1, and then how you get the next one, you take the previous number times 8/9, so I should put 8/9 in the front, for all n greater than or equal to 2. Now find the shaded, for C, find the shaded area of the fourth iteration of the Sierpinski's carpet. Okay, we already had it on the list up here, this one. So it's 512/729, and you could change it to a decimal, and that would be approximately 0.702 square units. Because remember, we always include the units. Alright, so here we have, they give you the thickness of a piece of paper, 1/10 of a millimeter, and it says when folded the paper is twice as thick. So find both the explicit and recursive rules for this geometric sequence. So we're going to call n the number of times that we folded the paper, and f of n is the thickness of the paper